So integration by parts is kind of like the next most common integration technique beyond just a straight U sub. So integration by parts is the undoing of the product rule from differential calculus. So let's go back and review the product rule from differential calculus. And I'm going to use very particular letters because I'm getting set up. So we're going to let our function f be the product of two functions u times v, where both u and v are functions of x. Okay? So when we differentiate it, so we'll go ahead and ddx both sides. Right, when you have to do the derivative of the product rule says it's the first times the derivative of the second plus the second times the derivative of the first. Okay? So this is df dx. So that's your differential calculus that you probably remember. So we go that way. Now let's work ourselves back out. So now we're going to integrate both sides. So we're going to undo the operation we just did. So now we'll integrate both sides. And I'm just going to go term by term because I'm, again, getting myself set up. So if I integrate df dx, so I'm integrating with respect to x, right? This is just undoing the operation we did. So I get back to f, and, well, I'll get there in a second. So I get back to f. So f is equal to the integral of u dv plus the integral of v du. Right, I'm integrating each of those terms with respect to x, so those dx's go away. And now, and you can move either one, it's just convention. We're going to go ahead and subtract this second integral from both sides, that term, and I'm going to replace f with its other version, which is u times v. So now I get u times v, that was my f, minus the integral of v du is equal to u, the integral of u dv. So you might be thinking, well, how does that help me? Well, because this is what you're going to start with. The integral of two functions or two quantities, two expressions that are functions of x, and you don't know the antiderivative. You can't do a u sub. There's not a set antiderivative. So sometimes when that happens, we can do this integration by parts, and we can create this other integral of v times du that we do know how to integrate. So this is the integration by parts. The integral of u dv is equal to u times v minus the integral of v du. So when you see one of these, the first thing you want to do is pick out, right, this is what you're going to start with. You have to decide who is going to be u and who is going to be dv. So let's go ahead and do a couple of nice examples so you can kind of get a handle on how you should pick your u and how you should pick your dv. So this first example is x times the cosine of 3x dx. So maybe you're thinking, well, isn't that just a u sub, right? So go ahead and think that out. So if it was going to be a u sub, we'd have u be this, right? 3x, so then du is a 3 and you'd get a 1/3. I still have this x out in front, right? So then I still have a product. I'd have a u over 3 times cosine u. I still have a product that I'm trying to integrate. And we do not have, right, a way to just integrate a product. We need, right, it either needs to be a u sub where we can get rid of one of the factors, right, have it get absorbed into that du, or, well, that's kind of it. So this isn't an option for that. So this is a u sub. So this is a u sub. When you're integrating a product and you can't do a u sub, then we go to integration by parts. So IBP, integration by parts. So we have to decide who's going to be u and who's going to be dv in this integrand. So as a general rule, if one of your factors is polynomial in nature, let it be u. Okay? Because, right, as I go to find my other parts, I'm going to take the derivative of whatever you choose u to be. And so if it's a polynomial, when I take its derivative, it's going to lose a power, right? So it's going to start knocking down so that hopefully I can get rid of it. So for this one, you would let u equal x, and so then dv equals the cosine of 3x dx. Okay. So look at your parts over here. So you need a u, a v, and a du. So far I have u and dv. So to get to du, we're just going to differentiate. So if u is x, then du is dx. And if dv is cosine 3x, to get to v, we're going to integrate. Okay? So if we want to integrate cosine 3x dx, so cosine goes to sine, right? And then we're gonna do the u sub in our heads, right? It's just that k factor of the x, so there's a 1 over k out in front, or a 1/3 sine 3x. Oh, I'm going to put my little cheat sheet just to make sure I don't get my pluses and minuses flopped. So if I integrate cosine, yep, sine, okay, good. So I have all of the pieces right here. So now I'm going to rewrite my integral. So this is the exact same thing as u times v. So x times 1/3 sine 3x minus the integral of v, which is 1/3 sine 3x du, and du is dx. Okay. So now I have x over 3. That doesn't have an integral symbol anymore because we've already done that part. So it's just x over 3 sine 3x, and now I'm going to integrate. Here's my integral. Okay. So I have the 1/3 out in front, integral sine 3x dx. So again, it'll be a 3 and a 1/3. So I'll just carry this guy along, x over 3 sine 3x. So I'll have minus 1/9, and then integrating sine goes to negative cosine. So that negative cosine and that negative sign will be a plus cosine 3x. And it was an indefinite integral, so we'll go ahead and put our plus c on there. Okay, let's do another one. We're going to do 2 more of these nice-ish ones. Okay. And then I'll do another video or 3 for some of the less nice ones. Okay, so let's do, so right, this is when we have a product. So how about x e to the 2x dx? So again, integral of u dv equals uv minus the integral of v du. I would have that handy, so it just helps remind you of what your pieces are. Again, how do you choose u? How do you choose dv? So here's our product, x times e to the 2x dx. If one of your factors is a polynomial, then that's what you choose to be u. It's a good first step, at least, a good first guess. So we're going to let u equal x. So then dv equals e to the 2x dx. So then I need du. So I differentiate x with respect to x. So that's just dx. You could have 1 dx if you wanted, but you don't need the 1. And then to get from dv to v, we have to do the antiderivative. So again, it's that k, right? So the only thing that's different is I've got, right, a 2x instead of just an x, so it's a 1/2 out in front. 1 over k e to the 2x. So once you get there, let's go ahead and rewrite our integral. So the integral of x e to the 2x dx equals u times v. So x times v, so x over 2, right, that's that 1/2, e to the 2x minus the integral of v, which is right there. I'll bring the 1/2 out in front. E to the 2x, so right here's my v, and then du is my dx. So I get x e to the 2x over 2 minus, so now I'm doing this antiderivative. So I have another k that comes out in front on the bottom when I'm integrating e to the 2x. So there's a 1/2 to start with. There'll be another 1/2 that comes along. So 1/4 e to the 2x. And then again, plus c. Okay, so for our last example, let's go ahead and do one that has limits of integration. So we'll do a definite integral. So let's go between 0 and pi thirds, x sine 3x dx. All right, so we've done this enough. I know that you know what to choose to be u. So u will be x. So then dv equals sine 3x dx. du equals dx. And v equals v equals, so sine goes to negative sign, so that will be negative 1/3 cosine 3x. So I'm going to leave off my limits of integration until I get to the end, and I go back to until I'm ready to integrate. So uv, so negative x thirds cosine 3x minus the integral of v. So v was negative, so I'll use that to get rid of that negative. So plus 1/3 cosine 3x v du, and du is dx. So I'll hop down here. So I have negative x over 3 cosine 3x. So now I have to do this antiderivative. So that'll be another, right, 1/3 comes out front, so it'll be a plus 1/9. And then cosine goes to sine, positive sine 3x. Okay, so these are all x's, and these guys, my limits were x's, so I don't have to do anything. I can just go ahead and put these guys back. And now we'll plug in. So I'll have negative pi thirds, and then that 3 in the bottom, so negative pi ninths, cosine of pi, right, plus 1/9 sine of pi minus 0, right? 0 goes here, so times the cosine doesn't matter, and then plus 1/9 times the sine of 0. So let's see, that goes away. Cosine of pi is negative 1, so I have pi ninths for my first term, so negative pi ninths times negative 1 will be positive. The sine of pi is 0, 0, sine of 0, also 0, so it looks like it's just pi ninths.